Yeah, so next we have Professor Lerothodi Leeuw, who is an astronomy professor at the University of Western Cape. And also as a particle astrophysics, he explores the intersection of astrophysics and particle physics and mentors work on the dark matter particle at the CERN laboratory. Welcome, Professor Leeuw. It's good to have you here.
Thank you. I guess I can start and you can hear me well. So I'm talking about the historical challenges of astronomy transformation here in South Africa. And I've outlined my talk like this, where I give it, the topic of transformation, some context from the human point of view, history, and talk about some issues therein, and then delve in to how those issues impact transformation and maybe a possible advancement. From this symposium, we are learning that history is indeed important. So I hope you will allow me to also look at history with relates to transformation. And I'm using transformation from this deep meaning of transformation being positive change in condition, nature, and character of people or societies. And it's actually like a human instinct that I think all societies, people aspire for to better themselves. And indeed, astronomy can be quite a powerful tool for transformation, as you've been hearing in many of these talks here. On the slide, I have an illustration of astronomy from the African societies here, ancient. And there it's showing Pleiades that was used by these societies for a calendar and to indicate a time for planting. We've heard all this. And also Orion there, which can be used for navigation. So indeed, astronomy can be used to help transform in all these ways, right? And on the right there, of course, the Cape Royal Observatory, which also itself was erected with transformation as one of its goals. We've heard about that, about how it was going to help with navigation and all the resulting positive transformation aspects that came from there. I quickly also just want to mention that in all these societies, astronomy also has these poetic interpretations, these methodological interpretations, both from our ancient societies here and those that and the modern ones. But both these aspects actually are there in both. It's not like one is more about mythology and folklore, and the other is more about these physical aspects. Just want to make that clear. And this transformation that we are talking about here is actually measurable. So it's not just like some vague thing that the left or people who try to pretend to be good talk about. It's something that's measurable. You can look at my own career or some individual's career and see how they've transformed. And you can also look at societies and see how they've transformed. Like, for example, measure PhDs per 1,000 people, engineers per 1,000 people, and really say what's going on in these societies. Now, South Africa's history, particularly the recent history of apartheid, has this implication that for us, transformation is not just simply this core thing about changing condition, but there's a racial element to it as well, because this apartheid disadvantaged African people. And so then it comes to this point where when we talk transformation in South Africa, it becomes a racial, a word that has, that's racially loaded. It's not that the meaning has changed about improving human condition. It's really just because of our history that it then becomes this, loaded word that's relating to race. And we really need, when we think about tackling this, that we are not talking about tackling race. We are talking about tackling the condition of improving humans and improving our country. In this slide here, I just show a timeline of astronomy in South Africa, and have put a log scale on this. With this 2 years there of Meerkat, Salt, 20 years, and Cape Observatory 200, and of course this other astronomy that existed way before that, 2,000 years ago, 20,000, and I claim even 200,000 years ago. And that claim, right, is because we have discovered tools that are that old in this area. And if you are making tools, I imagine you are also dealing with this, thinking about the sky and so forth. I guess I just want to mention that when we deal with history, we can choose what to emphasize and what not, and so at this very moment, just this particular symposium, for example, is emphasizing the 200 years ago, and I'm also going to just pick a small segment, particularly a segment that's emphasized in this particular timeline here, going from 1910 to 1950s, and then from the 1950s. So let me just dive into this part here, that it's important to consider the demographic of South Africa from 1910 to 1945, where if you use these racial divisions that I don't support, but they just happen to be what the country was using, then you see that the relative percentages of these distributions stayed the same from 1910 to 1945. What radically changed was just that there was massive urbanization, and that urbanization mostly of Africans going into cities. So you can use this timeline to see what was happening in terms of the historical changes of astronomy. That's the topic of this symposium, relating to the events, the political historical events at the time. And in the 1940s, what happened was this was really an area post-World War. There was a Great Depression in the country, national drought. And I already mentioned the African urbanization that, by the way, was linked with literacy transformation of Africans. So they didn't just go to the cities. They actually learned, a lot of people doing science then. And but unfortunately, because of this time, what happened at this time as well, the the National Party won and introduced apartheid. And again, you can relate this to the timeline that I already mentioned. And the introduction of apartheid came with these really terrible acts, the Registration Act by race, the Group Areas Act by race, and of course the Bantu Education Act, which limited science educations for Africans, and has a lasting impact on transformation of Africans. And really, this is at the core of the transformation challenge today. The this Bantu Education Act wasn't just like words, right? It had these big implications on spending on these different populations, as showed on these graphs here, where there was like just massive spending on white people compared to Black people. And again, you can also relate that particular period to what was happening in South African astronomy. The period 1950s there, you are learning that's when Ratcliffe, Republic and all were growing. It's also, I guess, important to mention that while there was this big attack on the development of Black people through this, Bantu Education Act, there was a big drive of nationally going for a scientific expansion. And I mentioned this was post-war, World War II. And essentially this kind of thing was not just in South Africa. World War II, right? Basically, this is when it became clear internationally that technology helps you trump. Technology is key for development, right? Because that war was basically just won because of technology, airplanes becoming really important, those nuclear bombs that, ended it all. So it became clear, including here in South Africa. And that's why, so there was a move even within the country to develop science, but racially, like for white people, excluding Black people, right? And this actually happened. Now, this has had a huge lasting, impact. And I'm just listing some of the things here. For example, that of our universities, it's only those historically white that essentially are, that are really involved in astronomy today. That historically white universities still get a lot more, money than Black universities, that they have better facilities, that there are almost no white students in historically Black universities because of this history. It also has a huge, you can also see the impact of this in terms of people, where there are like very few Black professors in historically white universities, very like no Africans who have astronomy research chairs, for example. Big impact. With time running out, I guess I'll summarize with, I won't go into details of these last slides, but mention that currently the African population is actually more than 80%, between 80 and 90. So whilst their access to science is very limited because of this history, they are actually a big part of the population, and we as a country cannot afford this. The last slide deal with similar despairing numbers about high school completion, about people in universities, and also about people getting degrees, where you see that in real numbers, Black people are like just marginal in terms of access to science, and in just despairing ways that the country cannot afford. So the big thing really behind these very, very terrible numbers, and you don't have to listen to my presentation to know them, you see them on the streets there, the real big thing, as I said, is because of our really terrible history, is because we have very few science teachers and role models, because this, those lack of facilities actually trickle down to the rest of the population. I've already talked about limited access to funds, poor environment, and so I'll leave it there. And I just wanted to end by mentioning some things that might, be done to help this. And this slide, I actually realized is quite limited because this slide concentrates on things like diversity and inclusivity that we can do in astronomy and that we are still not doing. For example, I mean, people still organize meetings where there's no Black person talking, or they are not represented there, and people at in who we are talking to now. So the presence of these things are around us. But I also there's something I haven't mentioned that could be included here, and that's mostly because it's more at a national level, and that really you need a big spending as well in Black people's education if you're going to change this history. So you really need a big injection into the population's science education if you're going to really change this history. And I haven't included that very important part here because it's more at a national level, I feel, and not at individual. But on this slide, I'm mostly focusing on things that you individuals listening to this might actually make a difference on. So that's the end of my talk. I just leave it with that summary there of what the talk covered, and also to say that astronomy indeed is pursued and advanced by people and can be used for development and advancing them. And as I said, it can also be used for disadvantaging them, but we can change that. And in this case, I guess just to say that, I'm not only talking astronomy, but science in general. Thank you.
Wow, thank you very much for the talk. I think I am really, really starstruck and very, very interested to hear more about this. But we do have questions, and so Jordan will just relay the first one.
Yeah, thanks. You mentioned that transformation is measurable, and I'm just wondering what kind of metrics you might use to measure that.
Yes, I guess I mentioned you can look at people graduating. So we actually have this information, in individual universities have their own what they call data intelligence centers, and they will tell you the numbers that are graduating, numbers by race. They give you, and you can look at this at different periods and see what kind of change has happened over those periods. As well as at individual university level, you can look at this nationally. The stats South Africa keeps these details, and they are public, so you can actually go there and look at it. Those are at these broad levels, right? You can also just look at smaller groups, your classroom, your astronomy group. I could go on about the metrics. I'm sorry.
Yeah. Well, Lerothodi, I just saw that you mentioned that there are about 12 professional astronomers. And, just relating your talk to what Patricia was speaking about with the NAS program, I mean, we see an intake of Black students coming into the program, into astronomy. So where is the loophole if we only have, now just started in 2000 and now it's 2020 and we only have 12 professionals? Where do you think the loophole is in astronomy and in the system itself?
So we have a big problem currently in terms of how we develop the young people, the young early career people, and that problem is actually so an issue of the positions, giving them positions to actually practice, particularly the early ones, and that's where that problem is. Some of it is at the national level, where for example, we don't really have a good structure for funding early career people. And I guess since I'm invited to give this talk, I really have to talk the facts as well, and also that they are poorly supported. I think in people in starting early careers. I mentioned that because of our history, our historically white universities have better funding, and so the people who make decisions at those universities also have this history, and not enough is happening there, where they are making like conscientious decisions to really make things different. How you change this is like a whole different topic. I mean, and I only have had 15 minutes here, so if you give me another 15 minutes, I can give you a really detailed thing.
Yeah, thanks. Sounds like some things that we need to start addressing. I was interested to hear you claim about some astronomy from 200,000 years ago. You mentioned they'd found evidence of the tools that were developed around then, so they must have been doing astronomy. Do you mean more like just observing the cosmos, or something a bit more scientific?
Well, I mean, so I don't think I can show my slide anymore. But if you in the slide you are mentioning, you have Meerkat there, you have Salt, and then Cape of Observatory, and then that period. Now, the kind of science that was done by the Observatory Cape of Good Hope is completely different to the kind of science that Meerkat is doing, and because of the tools that were available then, right? Like I could talk about some of that science and say, is this like just looking at the star, like counting the stars essentially? Is that all that you can do, right? And so 200,000 years ago, people were mostly like using their eyes and observed things, the rise and the moon, and made sense of their position in respect to that. But it's not just like mere observing because they were just using their eyes. It's the science that was there then. And I also think that image of the fire is actually very, very powerful, right? Because there's this story that the fire, this girl took the ashes, threw them there, and imagine this how the Milky Way started. So now this is really, really powerful scientifically, because one of the things that people have wondered about is what makes these stars shine, what gives them energy. And at the time, right, we didn't know about like nuclear fusion, or fusion. The science then was that heat comes from fire. So this girl actually like doing this and imagining that there must be another fire there that's giving these stars light. It's actually very, very powerful and scientific. It's not like some mere just a tale about fire and stars. I hope I've answered the question.
Yeah, thank you for that. I just have one more question, if you don't mind, please. So, in your talk, you have mentioned things like transformation and diversity and inclusion. But I just want to ask, in terms of equity, how are we doing as astronomy? Are we moving towards being more equitable? How are the numbers looking in terms of female astronomers, in terms of female and Black female astronomers, as well as other people of color in astronomy?
Great question. I think we've done well. So when I did my MSc at UCT, there were like two like Black students then, and the numbers are much better now. So you can do this sort of comparison and see that the numbers have improved. However, because of our really terrible history, and because of Black people are really a big percentage of our country, these numbers are not good enough, and they need to drastically improve if we are to be, better transformed as a country. And by transformed, again, I'm using the deeper meaning of transformation. If we are going to become this, country that can sustain and play a big role in the international community, we are just doing a terrible job, because we are essentially just leaving a big part of the population still uneducated and with no access to science. And of course, the terrible thing is that then they are left to like unemployment, no jobs, alternative economy, which includes crime. And so it's not acceptable that we are not, acting on this quick enough.
Yeah.
Thanks very much.
No, thank you very much. I think it's really been interesting to have you around. Thank you so much. We'll just let you go now, Professor.
Yeah, thanks very much to all the speakers for this morning's session. Just going back to what Saul said in the first presentation, it's quite interesting to hear about this rivalry between South Africa and Australia, and obviously both as hosts of the SKA. I mean, you'd hope this is like a healthy kind of competition. There's at least, I know of many examples of a more kind of collaborative environment. For instance, you may have heard of Sparks, the SKA Continuum and Polarization Working Group for SKA Pathfinders and Precursors. So this is very much a collaborative environment where they meet together, they share techniques about how they're able to do, roll out their telescopes, produce the data, do their surveys, and the techniques also of the science. So it's quite a useful collaborative environment. There's also the same with FISC, which is aimed at neutral hydrogen. And but perhaps do you think there is some health in kind of healthy competition?
Yeah, no, I think we've really definitely moved from enemies to friends in the sense that we are always looking forward to growing this astronomy worldwide, and not just for our own countries or for our own personal benefits. And I think one of the things that this session has also brought was the importance of transformation, the importance of supporting our students, and the importance of really, really moving astronomy to be seen as a mother of all sciences. I mean, I know that most of the people will look at you and like, oh, but what does astronomy do for Black people? But in this sense, you can see that astronomy can be used as a tool to introduce us to even more and more sciences.
Yeah, very much so.